also experienced bilharzia problems, but they eradicated it using a particular method. Okay? You can use, you are not sure whether if you use that method, you can eradicate bilharzia in your case. But you can suggest that I suspect that if I use this method, which was used in China, it was also used in Malaysia, it was also used in India, and in all these countries, bilharzia was eradicated. Then you can come up with a hypothesis to say, if I use this method, I will eradicate bilharzia in Malawi. And let's say, for example, through your study of the literature, you find that China, India, Malaysia used a particular method and they eradicated it. And then other studies show that Colombia, Brazil, Ecuador used another method and they also eradicated bilharzia. Another set of studies shows that in Ethiopia, Somalia, Sudan, they also used another method and they eradicated bilharzia. Then you can come up with 3 hypotheses. Using this method, applying this chemical in our water would eradicate bilharzia. That is all, the chemical which was used in China. By drying out all waterlogged places, I will eradicate bilharzia. Maybe that's the methodology they used in Brazil. By giving this drug to create resistance in people, I will eradicate bilharzia. Maybe that's the method they used in Egypt. So you can come up with your hypothesis for those 3 methods. So you have 3 methods to test and to see whether bilharzia will hold. Then you can have a group of people in the bilharzia prone area, treat them with one method and see whether it works. Another group of people, you treat them with the other method and see whether it works. Another group of people, treat them with the 3rd method and see. And you can compare in the end to say, which one of these have worked? From such a study, if you do that and you collect data among the people you have treated and you find that there is no trace of bilharzia, now you can come up with a recommendation to say use this drug to eradicate bilharzia. And with that recommendation, the development problem we started with can now be dealt with using the knowledge you have generated. Is it making sense? So, by studying the literature, you can generate hypotheses of what is known, what was observed, or there could be hypotheses from deductive reasoning yet. But you have to jump to test that hypothesis in your own specific situation to confirm or disconfirm what is known in the literature. Am I making sense? I'm making sense, right? I'm hearing, but not strong ones. At the corner, is this making sense? How do you generate a hypothesis? An easy one. You ready? How do you generate a hypothesis? Yes, sir. Yeah? In the cream t-shirt. How do you come up with a hypothesis?
You understand the problem. You try to understand the problem.
You try to understand the problem by doing what?
By doing research.
Uh, this whole process is about doing research. Yeah, but what part of this process is that? Once you have come up, once you have defined the problem, you need to go into the literature to search for possible solutions to your problem. And when I went to look at studies done in China on how they eradicated bilharzia in China, what am I doing? I'm looking for a possible solution for bilharzia eradication in Malawi. So I have found one possible solution on research done in China. When I went to Brazil, I was still looking for possible solutions. And in Brazil, I found another possible solution. Then I went to Ethiopia and I found another possible solution of what people did in those places. And I'm taking those possible solutions to implement them in Malawi in order to see whether those solutions are going to solve my gap. So literature. We'll be talking about literature quite a lot in research. If you guys don't like reading, sorry, you become an enemy to me, because now you must be readers. Okay? So reading is going to be a very important process of research. Actually, the whole deductive reasoning we're talking about is reading it. How do you come up with those facts? You have to read. The whole induction I was talking about is reading it. How do you come up with facts which were observed elsewhere? You have to read. Okay? So, once you have come up with those hypotheses or research questions, then you can also use deductive reasoning to say, now if I have to conduct an investigation to test whether the hypothesis I have made is correct or not, how should I do that? So we'll be talking about the methodology of conducting your research. In Brazil, they used a particular chemical to eradicate the bilharzia. So I can use that chemical. But I can have the chemical there. If I don't apply it the way it is supposed to be applied, is bilharzia going to be eradicated? No. So what is the methodology I need to use? That is also a process of deduction. And that process also will require you to go into the literature. How have people used it? And if the people have used it this way, how am I going to use it in order to assess whether it really works in Malawi? Okay? So that's when now we're becoming the research design, the data collection methods, the data analysis techniques and all those things. You don't just come with those by dreaming. You have to come with a specific logical process, step by step. If people will later on read your work and say, ah, yes, she did a very good process of research, and that research she did has come up with good findings which have led to recommendations we can trust, and we are going to implement our actions using this recommendation. Because you recommend, now if you want to eradicate malaria or you want to eradicate bilharzia, these are the methods based on your findings, right? And those findings must come from methods which are correct. And then you find even government saying, from now onwards, government has made a policy that people who are living in flood-prone areas or waterlogged areas should be using this method to prevent or to eradicate the bilharzia based on your research. And then using your research, people are now coming on ways on how to deal with the development problem we started with. Okay? The deductive reasoning will now describe the methodology, but then you must implement that methodology so that you come up with the data you need to confirm whether the hypothesis you made is correct or not, and how are you going to analyze that data you will collect in order to confirm that the hypothesis is correct. Once you have collected the data, people will expect you to come up with conclusions of your work. And the conclusions must be designed in such a way that you reject the hypothesis or you accept the hypothesis. If I've used the Brazil method for eradicating bilharzia in Malawi, and in my experiments, the Brazil method has not worked. I've applied it, and then I've gone out to collect the data to see whether those people who received this treatment have bilharzia or not. And I find that there is still bilharzia among them. Then I cannot confirm my hypothesis. But watch the language I'm using. Here I must be specific. If I fail to confirm the hypothesis, I don't end up concluding that the hypothesis is wrong. That's not the language we use. I only say that the hypothesis has been rejected. That's why I'm using the word rejection in this case. And I'll explain why we do so. If I've done my experiment and I find that using the treatment I gave, nobody in the people who were treated has been found with bilharzia, then it means the treatment is working yet. I will not conclude to say the hypothesis I made to say that if I treat people using this method, they will all be treated from bilharzia is true. That's not the conclusion we make. The conclusion we make is that based on the data I found, my hypothesis is confirmed, or my hypothesis is supported. That's the language we are supposed to use in science. Why do we use that type of language? You remember when I was talking about Francis Bacon's argument said, I was saying that it is not possible to study each and every case in a population. It's difficult to conduct perfect induction. We only make observations and we come up with conclusions based on the few observations we have made and generalize them to the whole population. But that generalization does not mean that each and every case in the population has been started. Let's assume that all the goats that have been observed are warm-blooded, and you also have observed your goats and they are warm-blooded, but there is still a goat elsewhere which has never been observed and is cold-blooded. Now you say your hypothesis is correct. Is that correct? No. You have only confirmed what is known with the data you have generated. You are still not sure whether it's correct or not, but you can confirm and you can reject based on what you have observed. You don't know what is existing elsewhere. Maybe if the study was conducted elsewhere, the hypothesis you made was going to be confirmed or supported. So you only reject, but you don't say the hypothesis is false. No. You don't say the hypothesis is true. No. That is just the way, as scientists, we speak. Okay? So the way you write your results, you don't say your hypothesis is true. You don't say your hypothesis is false. You only say supported based on your results or rejected based on your results. I hope I'm making sense. Questions about the steps we go through in the scientific approach before we start going into more detail? And we said earlier on that all research starts from definition of a problem, right? So I don't need to repeat that. But when we come up with a research problem, we need to assess whether the research problem we've come up with is a good one or not. There are specific characteristics that a research problem must satisfy. And one of the characteristics is that it should be stated in such a way that observation or experimentation can be done and provide answers to that problem. We said that the problem is about a gap in knowledge, yet that gap should be stated in such a way that you can be able to go out and conduct observations which will help you to generate knowledge to close that gap. Or in such a way that you are going to go out to conduct an experiment which will help you generate information and knowledge to close that gap. That's a very central characteristic of a good problem statement. So issues of value have no place in a problem statement. What am I saying there? You know that as we are here, there are certain people who like to be seeing blue things. If they go in a shop to buy a shirt intuitively, they'll be looking for blue shirts. Others will say, I like white. So intuitively, they'll just be going for white shirts. Anything which has white colors, they'll think that is good. Whilst this other person says, anything which has blue colors is good. Why is he defining white as good? It's just a value. It's just a liking that he has. But there are no real facts to say that white is better than blue or blue is better than white. It's just your own likings. Now, if you state a problem which is based on just your likings or just your values, things which you think are important to you, that one doesn't lend itself to observation. How do you go about to be observing the things I like in my mind? Challenge it. It should be something which you can be able to observe. Of course, in the same example of making it, of shirts, I can state a problem statement in a different way to say between white and the blue colors, what do the majority of the people like? Now that one I can observe because I can take you all to a shop, give you enough money to buy dresses and shirts. And when you go to the shop, I observe and say, what do you want dress and lunch, or you want shirt and lunch, and count how many people have bought the white shirts, count how many people have bought the blue shirts, and be able to say, the majority like blue. But measuring the value in this majority about the goodness of blue, the goodness of white, I can't do that. Okay? So when you are starting your problem statement, it should be in such a way that you can make observations out of it. Okay? So value judgments, troublesome in science. They have one place where you can talk about them when you are talking about evaluation, because evaluation is about the value judgment. But pure science, am I right? Then we have talked about the hypothesis, where we are saying it provides a tentative explanation to the problem, and I'm saying it requires review of related literature and much thought. Why am I saying much thought? Deductive reasoning, deduction, Rayon did a study in China and found that the goats in China were warm-blooded. Yamikani did a study in Brazil and found that the goats in Brazil are warm-blooded. You have tricked me. Sharon. Yeah, Sharon. Okay, that one was here. She has gone somewhere missing. Sharon has conducted a study in South Africa, found goats in South Africa warm-blooded. Now, the much thought would be to jump from there to say goats in Karonga are warm-blooded. It must be based on the connection of facts which have been observed elsewhere. Okay? Questions? Yes.
The problem.
Problem.
Yes, we talk about two examples, which we talk about developing problems and then research problems. So what I want to ask about is it always has to be an actual problem, or maybe we can find another solution like it? So we enter the type you want to find out.
I'm not following your question.
Okay, let's say there's already something that's really working,
Mm-hmm.
and then you want to research on something that, if you add this, can improve upon maybe your lifestyle setting. It can also be like a research problem.
Okay, one problem is that your friends have not heard. The other problem is I'm still having trouble to understand what the.
Okay, let's say, for example, I'll give an example. Right?
Hey.
There's point A to point B.
Yeah,
So
yeah.
people use method number one to
Hey.
get from point A to point B.
Yes.
So you want to find another solution which is faster than method number one.
Yeah.
Okay, can I also do like a research thing on
Oh yeah. It's a good question actually. Sorry, we're not understanding it. What's your name?
Bliss. Bliss.
Bliss.
Bliss.
Blisse.
Bliss.
Blessings.
Bliss.
Bliss.
Bliss. B-O-I-W.
B-O-I-W. Bliss. Okay. Hey, Commandant Alepera. 0%. Okay. Bliss conducted a research and found that the best way of treating bilharzia is to dry all the stagnant water places in Lake Chirwa. Then if you don't have stagnant water places, bilharzia will be done away with. And we're going by that knowledge. But you can actually say, by removing the stagnant water places, we cannot grow our vegetables, because for us to grow vegetables, we need good moisture. Then you drain out all the water. Now, I want to come up with another methodology of eradicating bilharzia, which will not have to make us kill our livelihoods of growing vegetables. And you study another methodology of doing it. That methodology is a gap which you are looking at. So, the gap in knowledge may be the gap in terms of treating bilharzia. It could be in terms of methodology for doing it. Maybe there could be another better methodology than what Bliss came up with. And in research, those are a lot of examples you will find. Somebody used this methodology to investigate a particular issue. But The research methodology now is it doesn't seem to be good enough. And we are saying, is there any better methodology for doing this? That is also gap. When you generate knowledge, you are helping other researchers who will be doing similar studies to use your better methodology. So yes, that can be a gap. I hope we followed his argument. Oh, you didn't follow? He was not sure the way he was raising the question. But his question was, he used, because of our continuous questioning, he used an illustration. Say, okay, if there's a methodology of moving, traveling from Karonga to Lilongwe, which we have been using, and the methodology we have been using is a minibus. Can I come up with a problem to say, is there any better methodology of traveling from Karonga to Lilongwe? Can usage of a bus be better than usage of a minibus? That can be a good research problem. In other ways, if some people have done the research using a particular methodology, are there better methodologies? And that's very common when you are studying. You will find that, okay, this person used this methodology, but it didn't seem to work out very well. There are certain problems. And you can come up with your own problem statement to say, are there any better methodologies for doing this, which are better than this methodology? And you can come up with hypotheses, proposing what you think are better methodologies. Of course, the hypothesis has to be supported by fact set. And you can go out to investigate and confirm to say, using a bus is actually much better than using minibuses to travel from Karonga to Lilongwe. It's clear, right? Okay. So this is what I was saying, using the deductive reasoning, the implications of the suggested hypothesis, what is supposed to be observed is determined. So in other ways, you suggested a hypothesis that if I use this treatment, my population in Zomba is going to have is not going to have bilharzia anymore. If I use this methodology, I will eradicate bilharzia in Zomba. Now you must state how that reasoning can be assessed for you to confirm your hypothesis. Okay? And we are talking about the methodology now. The next time when we meet, we can talk about the actual data collection methods. The previous slide? Any question on it, or you just want to see it? Somebody is still writing. Okay. Actually, my computer is also saying goodbye. I know it's okay. Yeah, thanks. Asante sana. Asante sana. This pen is not mine. I found it here. I think one of the lecturers who came in the area is the one who lost it. Yeah, it's yours. Tatogoza. Are the things we are talking about making sense?
We are just introducing.
Oh, okay.
So it's